Previously, we had looked at acids and bases from the perspective of trying to write net ionic equations. So we're going to look at it in terms of equilibrium at this point. So just to review, their strong acids are your halic acids except for HF. So HCl, HBr, HI, and then those that have two more oxygens and hydrogens. So nitric acid, sulfuric acid, perchloric acid, and chloric acid, sorry. I have those backwards. So this one's chloric and this one's perchloric. So I'm thinking faster than I'm writing. So again, that's your guideline. Oxyacids, the number of oxygen exceeds the protons by 2 or more. Okay, there's way more weak acids than there are strong acids. So organic acids always have this COOH, and that's really part of the structural formula. So if we were drawing the Lewis structure for this, we would have our pairs of electrons, and then there's a double bond, an oxygen and a hydrogen, and for oxygen to have it's 8 electrons. We often draw it like this, but remember it's really a bent molecule. So if we're really doing true to the structural formula, there'd be 2 electrons up here, and this oxygen actually has that bent structure. So the acid hydrogen is this one here. So again, because of the hydrogen bonding, there's a lot of electron draw here. All right, then your strong bases are your hydroxides of group 1A, or again, just your periodic table of group 1, and barium hydroxide. So again, barium's far enough down the list that it doesn't hold on to the hydroxides as well, so they ionize equally, or very well. So you're introduced to this. Ka is the equilibrium constant for acids dissociations, and Kb is the equilibrium constant for the dissociation of a base. Now, just like we have pH, which is the negative log of the H plus concentration, you're going to see pKa's, which is the negative log of the Ka, and pKb, which is the negative log of Kb. All right, so the next piece gets actually into the equilibrium piece. You typically will not find Ka values for strong acids or Kb values for strong bases because they are completely ionized. So those numbers are so large, they just don't matter in terms of doing calculations. But this is important. The larger the Ka value, the stronger the acid. So if you had something that was like 1 times 10 to the negative 7th compared to 1 times 10 to the negative 9th, the one that was 1 times 10 to the negative 7th would be a larger or a stronger acid. And then opposite is true, and again, think of this in terms of pH. The smaller the pKb value is, so that's just Ka. If you take the negative log, just like lower acids are, lower pH values are stronger values, pKa's are stronger. So a smaller Kb is more basic, and a larger pKb is a stronger base. And then you have this other very important relationship. So if you know one part, a Ka or a Kb for a conjugate acid-base pair, you can find the other one through this relationship. So product means you're multiplying them. So you saw that relationship in the pH packet. So you could have Ka times Kb equals Kw, and that flows exactly from here. The pKa plus the pKb is 10 to the 14th. All right, and then this idea of acid-base conjugates. So if we take 1 hydrogen off of this one, we're going to have HSO4 negative. And because it's losing a hydrogen, it's going to be an acid. If we have HSO4, we actually have an option. I can add the H back on, or I can take one off. So this is amphoteric. So if it's acting as an acid, you're going to get SO4 minus 2. If it's acting as a base, you're going to get H2SO4 back. Okay, CO3 doesn't have any hydrogen, so that's a base. It's going to accept a hydrogen and become bicarbonate. S-2 is also a base. It's going to accept a hydrogen. Okay, HNO2 is going to be an acid, so you should recognize that one as nitrous acid, and you're going to get the conjugate of NO2. And then NH2 you'll see is in minus sign, so it can be either. It can accept an acid or a hydrogen to become an NH3, so if it's acting as an acid, then it forms NH3, and if it's acting as a base, it is going to sorry, I said that backwards. When it's acting as a base, it's accepting a hydrogen and forming NH3, and if it's acting as an acid, it's donating. Sorry, NH3 is just my go-to for that one. And it would be just NH minus 2 if it's donating another hydrogen. This is your conjugate. So you'll see some of these in the next video.